You are welcome to Science Tutorials with Eternity the Schoolboy. Today we are going to take a look at chemistry and we have a question on the board. The question says, A. Copy and complete the table below. Volume of pipette 25.0 cm3. This is the reading. This is the rough. First reading, second reading, third reading. Now the first attempt, second attempt, third rough, first attempt, second attempt, and the third attempt. And this is the initial burette reading, final burette reading. And this is the what? The difference. Now B part says calculate the average volume of A used. The C part says A is a solution of hydrochloric acid of unknown concentration. Full stop. Solution B contains 10.6 gram per dm cube of sodium triiocarbonate 4. Using the table above, calculate the concentration of B in mole per dm cube. A in mole per dm cube. A in gram per dm cube. These are the relative atomic masses of the elements. Alright, so let's solve this question. This question is titration. We all know that. It's titration. And this is the reading. Actually, in exam condition, you are supposed to answer this A part, you should copy the table, then fill in the spaces. But for the purpose of this class, let's just fill in the table directly. Please, in exam condition, you need to copy the table, because if you copy the table separately and fill it, it has its own work mark. This is the A part of the question. Please don't just fill it into inside the box, inside the table like that. Copy it, draw it separately, then fill in. Now let's go. Okay, now let's just do it directly for the purpose of this lecture. Now, this is the rough. We don't use the rough. You know, a lot of things happen in the burettes, deaths, other things, rinsing, all those things. So we don't count whatever reading because it may contain impurities. So we don't count them. We don't use the rough. We start from the first reading. Now, the first one says here, this volume of A used for the first titration is actually the final reading minus the initial reading should give you this. So if this minus this should give you this, therefore to get this, this should now be this plus this, which is what? 30, which is what? 34.50 in cm3. Now, for the second titration, this is the final reading here is 24.40 minus 0.00. So this will now give you what? 24.40. Now here is, there is nothing here. So if this minus this should give us this, therefore to get this one, just add this and this. So this plus this is now what? 39.3. 39.30. So we have filled the table. So we have answered question A. Now let's go to question B. Question B says, calculate the average volume of A used. Now this is the first titration, second titration, third titration. So to get the volume of this of the acid used, we add this, don't add this please. We add this, and this, and divide by 3. So let's go. So volume of A used, average volume of A used is 24.50 plus 24.40 plus 24.30, all in what? cm cube, divided by what? 3. Divided by what? 3. So this will give us what? If you add them up, it will give you 73.20 cm cube divided by 3. And this will give us 24.40 cm cube. So the average volume of acid used is 24.40 cm cube. Now let's go to the C parts. This is B. Let's go to the C parts. The C part says A is a solution of hydrochloric acid of unknown concentration. Actually, we don't know the concentration of the what? The hydrochloric acid. Then B contains 10.6 gram per dm cube of sodium triisocarbonate 4. Now, using the table above, calculate the concentration of I, that is B in mole per dm cube. Now let's go. Remember, this is the concentration of sodium triisocarbonate 4 in gram per dm cube, which is mass concentration. They want us to find the concentration in mole per dm cube, which is molar concentration. There is a relationship between molar concentration, mass concentration, and the molar mass. And it says that molar mass in gram per dm cube, gram per mole, is equal to mass concentration in gram per dm cube divided by molar concentration in mole per dm cube. So this is a powerful relationship between these three parameters. So here now we have this. So what we are looking for the molar concentration. So let's make molar concentration the subject of the formula. So that means if you cross multiply, let's use molar conc to represent molar concentration. Molar conc is now equal to mass conc over molar mass. Now, mass concentration, mass conc of sodium triisocarbonate 4 is 10.6 gram per dm cube. So, for sodium triisocarbonate 4, mass conc is equal to 10.6 gram per what? dm cube. Now, what is molar mass? Molar mass of sodium triisocarbonate 4 is, remember, molar mass is the mass of the mass of 1 mole of a compound. So molar mass of a compound sometimes is the mass of 1 mole. Now, 1 mole of sodium triisocarbonate 4 is it can be represented like this. Even though this one is not one is insignificant, but let's put it so that we understand what we mean by. So this is mass of this 1 mole. 1 mole of this. Mass of it is what? To be able to calculate the mass of 1 mole, we look at the component elements of this compound. Now we consider the mass of 1 mole of each of the atoms of the elements that form this compound. So now let's go. This 1 mole of this thing, 1 mole of sodium triisocarbonate 4 contains 1 mole. Let's bring out this one outside. Contains 1 mole. 2 moles of sodium atom. Contains 2 moles of sodium atom plus 1 mole of carbon atom, 1C, plus 3 moles of oxygen atom, 30. And mass of 1 mole of an atom is will now lead us to making use of its relative atomic mass. So using the relative atomic mass of each of these atoms, we can now calculate the molar mass of the compound. Let's go. Still bring out this one here, even though it's insignificant, but I just want to put it to show us something. Now here is 2. 2 times the electric atomic mass of sodium is what? 23. 2 times 23 plus, remember this is in what? Gram per what? Mole. Plus 1 times electric atomic mass of carbon is this cannot be 13. Sorry, this is 12. Sorry, this is 12. 12. That of oxygen is 3. Oxygen is 16. All in what? Gram per what? Mole. Gram per mole. So if you sort this thing out, you now have something like this. This time this is 23 plus 12. 16 times 3 is 48. Hope I'm right. 16 times 3. Sorry, this is 46. Sorry. 46. 48. So if you add up this everything now will now be what? Gram per what? Mole. If you add up this, it will give us 46 plus 12 plus 48 is 60. Plus 46 is 106 gram per mole. If you multiply by 1 is insignificant here. So the answer is 106 gram per what? Mole. So the molar mass of sodium carbonate 4 is 106 gram per mole. Let me clean up so that we can continue. Alright. So, no, let me leave here. No, let me clean. Let me write out a value so I don't forget. We have established. Let me write it here. We have established that the average volume of acid used is what? 24.40 cm3. We have also established that the molar mass of hydrogen carbonate 4 is sodium carbonate 4 is 106 gram per mole. That of the mass conc is 10.6 gram per dm3. So we are looking for molar concentration. Alright, let's clean. I can now confidently clean this. So having done that, we'll continue. Remember, we are looking for what? Molar conc. Molar conc is equal to what? Mass conc over what? Molar mass. Remember, we established mass conc as 10.6 gram per what? dm3. We established molar mass as 106 gram per mole. So if you divide this, it will give us 0.1. Hope I'm right here. It will give us 0.1 mole per dm. This will give us 0.1 mole per what? dm cube. 0.1 mole per dm cube. Now, this is the molar concentration of acid. You can call it Ca. Yes, molar concentration of the what? Acid. We have gotten Va, we have gotten Ca, we are getting to somewhere. So we've answered, base, not acid, base, not acid. We have gotten the concentration of base in mole per dm cube. Now let's find the concentration of the acid in mole per dm cube. To find this now, we now go to the equation of this is actually a neutralization reaction between hydrochloric acid and sodium carbonate 4. So we'll now get to the equation of the reaction. From there, we'll take it up. Remember, the equation goes like this plus this. This will give us what? Sodium chloride plus water plus carbon dioxide. This is a gas. Bro, this is liquid. This is what? Aqueous. This is what? Aqueous. This is what? Aqueous. So let's balance the equation. Sodium is 2 here. So sodium should be what? 2 here. Let's go. Hydrogen is. Let's put 2 here. Chlorine is now 2. So hydrogen 2. Chlorine 2. Sodium 2. Carbon 1. Oxygen 3. 1, 3. The equation is balanced. Now, what is the mole ratio of the reactants? Hydrochloric acid is 2, while sodium tricarbonate 4 is 1. Now, let us now go to the popular equation, popular formula we know, which says that CAVA over what? CBVB is equal to what? NA over what? NB. This NA is mole ratio. NA is mole ratio of the NA over NB is mole ratio of the hydrochloric the acid to the base, which is 2:1. So NA is 2, NB is 1. Let's go. We are looking for what? The concentration of the acid in what? Mole per dm cube. So we are looking for Ca. So let's make Ca the sort of formula here. That means Ca will now become what? Ca will now become what? Cb, Vb, and what? A over what? Va and what? B. We cross multiply to get this. So now let us list their values. Ca is what we are looking for. Va, remember we got it to be what? 24.4 dm cube, 24.40 cm cube. Then Cb, we got to Cb here to be what? 0.1 mole per what? dm cube. Then V, what else? Vb, remember Vb is the volume of the pipette. Remember, the pipette we take 25 before the titration, take 25.0 cm of the sodium tricarbonate 4 in the pipette, put it in what? In the what? Conical flask. Remember, then the acid will be in the what? Burette. We now titrate the acid against the base while we are shaking using the what? Indicator to check the what? Change the color. So that this one is elementary titration we know. So the volume of base is actually the volume of the pipette, which is what? 25.0 what? cm cube. Now, Na is equal to 2, while Nb is equal to 1. Na is equal to 2, Nb is equal to 1. So if that is the case, we will now substitute to find our Ca. Ca now becomes what? Cb here is what? 0.1 mole per dm cube times Vb is equal to what? 25.0 cm cube times Na is what? 2 all over. Va is equal to what? 24.40 cm cube. Remember, see it here. Times Nb is equal to 1. So if you multiply this thing out, it will give us 0.205 mole per dm cube. This will give us 0.205 mole per dm cube. So the concentration, we go to II, the concentration of the acid A in mole per dm cube is 0.205 mole per dm cube. Now let's go to the next question. The next question says, let us now find the concentration of A in gram per dm, that is mass concentration. So let us clean up. Remember, we've got to the molar concentration of A, Ca to be what? Okay, let me clean from up. Okay, I'll leave this formula because we will still need it here. Alright, let me stop here for now. We still need this formula. We are solving what? I. We still need this formula that says that molar concentration is equal to mass concentration over what? Molar what? Mass. Molar concentration is mass concentration over what? Molar mass. Molar concentration is what? Mass concentration over what? Molar mass. But you are looking for what? Mass concentration in gram per dm. Remember, this one is in what? Mole per dm cube. This one is in what? Gram per dm cube. This one is in what? Gram per mole. Remember. So with this now, we are looking for the mass concentration. So we make mass concentration the subject of the formula. We now have that mass term in gram per dm cube. Remember, is now equal to what? Molar concentration, molar conc, a mole per what? dm cube times molar mass. Molar mass. Gram per times molar mass in gram per mole. We are looking for the mass concentration, remember? So if that is the case, we'll now have something like this. Okay, sorry. Of course, the molar concentration is the Ca, which is what? So molar concentration, molar conc is equal to Ca, which is equal to what? 0.205 mole per what? dm cube. Now, molar mass of hydrochloric acid is what? Remember, molar mass is mass of 1 mole. Mass of what? Let me write it out. Of 1 mole of what? Of hydrochloric acid. Mass of 1 mole. And 1 mole of hydrochloric acid is something like this. Look at it. So that means, remember, 1 mole of this now, 1 mole of this contains 1 mole of hydrogen atom plus 1 mole of what? Chlorine atom. All in what? Gram per mole. Now we go back to the relative atomic mass of each of the elements. Hydrogen is 1, so this now becomes 1 in bracket 1 times 1 plus 1. Chlorine is what? 35.5. 35.5. All in what? Gram per mole. All in what? Gram per mole. This will now give us what? If you multiply out, you have 1. This is 1 plus 1 times 1 is 1. 1 times 35.5 is 35.5. All in what? Gram per mole. So this one is insignificant. So we just add. I just leave it there for you to understand what we are doing. If you add this up, you give us 36.5. This is now 36.5 gram per mole. Gram per mole. So molar mass of hydrochloric acid is 36.5 gram per mole. Now let's go back to the equation, the formula. We say that mass conc is molar concentration times molar mass. So let's good. Therefore, mass conc of HCl is now equal to what? Molar conc of HCl we got here is what? 0.205 mole per dm cube times this 36.5 gram per mole, which is the molar mass of HCl. If you multiply this thing out, what will it give us? If you multiply this thing out, it will give us, let us not waste time, it will give us 7.485, yeah, something like that. It will give us 4.825 gram per what? dm cube, which we can leave it at 7.5 gram per what? dm cube. If you approximate it, it becomes 7.5 gram per what? dm cube. 7.5 gram per what? dm cube. So the mass concentration or the concentration of A in gram per dm cube is 7.5 gram per dm cube, approximately. Okay, this is the end of this question. Thank you very much for your attention. Please, if you have any question, chat me up on WhatsApp. The WhatsApp number is on the screen. And to watch our lectures online, feel free to subscribe to our YouTube channel. The name is Suzem Academy. There you see academic videos from our company. If you wish, you can also subscribe to our YouTube channel, Suzem Limited. There you see other videos that are not only academic. Then you can also subscribe to my personal YouTube channel. The name is Farmeternity, the Schoolboy. There you see entertaining videos in all aspects of life. Okay. My name is Farmeternity, the Schoolboy. See you next time.